the level, it will be able to monitor for you by color. So this is run on, let's say, different kind of sediment. Check on the recovery is very good. I mean that within 10% across all the elements for this geological sample cover from as high as percentage level as low as ppm level So this is on accuracy. Now we are looking at the stability, long-term stability. We also can monitor on this internal standard, the drifting of internal standard. So now we also look at this the stability of this element, like for most element 0.4 ppm. These are the major elements normally present in the soil, very high, 100 ppm. So monitor for about 8-hour running stability is within plus minus 10% for multi-element analysis. This is the geological sample, like I would say, to be analyzed on ICP-MS. Like for the same sample, also there are people to analyze on X-ray. X-ray will be like press powder fusion, then analyze on X-ray. Let's say using acid digestion, you'll be on ICP-MS for this element for raw geological sample. Next, we are looking into REE, rare earth element. Rare earth element is different from this raw geochemical because basically this element present at the very low level in the earth. So it's low level. So that this element means that GD, SM, PR, ND, LA, CE, these elements normally present at a very low level. But in fact, this rare element is more expensive than gold. And Malaysia good is full of rare earth elements in many states, as you will know. Okay, what are the uses for this rare earth element? Like LA, camera, telescope, lenses are using LA. CE, catalytic conversion in car. GD, X-ray tip, MRI scanning, all are using GD, rare earth element. PR is a strong metal in aircraft engine, high power magnet. A very little, very strong magnet. You can look into it. The old one speaker very big, but now very tiny because using rare earth element improve the size and also very powerful. Like TVEU is television, computer screen, radar. So rare elements are important. Okay, so now look into it. For example, rare element to analyzing LRA is challenging. For your information, if using ICP-MS to analyze rare element, because it's already low, after sample prep, basically they may not be seeing anything. Or certain element, maybe LACE in Malaysia high, very high, you may see it. Low level, you cannot see it. But ICP-MS, you can see all the rare element. So the challenging of rare is low concentration, and rare element got a lot of interferences, like oxide interference, doubly charged ion interference, and also multi-isotope isobaric interference. So like there are few techniques of doing it, like fusion versus microwave. Fusion, like the fusion after you fuse it can be analyzed on laser, mean that X-ray for the same fuse bit also can put into laser ablation ICP-MS. Because just now we mentioned that ICP-MS can analyze liquid sample. Yes, if there is accessory, we call laser ablation to be able to analyze solid sample. Okay. The red element basically on this range scanning, i-CRIM, LE is the red element, and the other is also these are the red element. So red element is very easy to form oxide in the ICP plasma there because it's affinity to form oxide. So now look at this chart, very interesting. So look at this. TB is this red element, mass is 159. Now look at ND, ND 142. ND, it got many isotope from 142 to 150. Okay, as long as this ND 99%.
It's okay.
Okay, this ND 99.99% overlap with other elements. So for example, 142, these are ND, if form oxide, ND oxide plus 16 interfere. And look at these TB, TB is mean there is this one thing, it will interfere by this ND as well. So in this case, it will have a problem. Like TB, the problem is a monoisotope. TB mass is 159. Okay, 143 ND. ND oxide 143 is the mass exactly as TB. So in this case, if you are analyzing TB, it may be TB or maybe from ND oxide 143. And also mean that this is the possible interference, and across all the elements it interfere one another. Next, look into it, HO. HO is also monoisotope. Monoisotope at 165. 165, for example, is minus C, it will be 149. 149 SM. SM 149. SM oxide will interfere with this HO. So in this case, what does it mean? That light rare element on this group interfere on heavy rare element. So rare element, there are two groups, light rare and heavy rare. In fact, heavy rare element is even more rare, more expensive. So very high value. So analyzing these rare elements is very challenging, and is ICP-MS is a solution. So now we look into it. In the ICP-MS, we know that it can form oxide. For example, if from TB, it interfere by this maybe like HO. What we are doing here is, in the ICP-MS, okay, we are moving this TB 159 to add in oxygen. It become add in 16, become 175. Move away from these are all the easily interference element. So mean that we can move into TB oxide or TB dioxide, mean that by adding in oxygen, same thing as HO. So in this case, in the analysis, like in the ICP-MS for this element, we are analyzing TB, we add oxide to move precursor TB to product ion TB oxide. Same thing as HO, we add oxygen in the reaction cell. ICP-MS got Q2, got reaction cell, convert precursor to product ion, ion at a different mass. So because the precursor ion there got a lot of interference, move away from it. So look at this chart. These are the rare elements, 15 lanthanide plus 2, like scandium, yttrium, La, and so on. These are the rare earth elements. So for example, if we move TB to other mass, means that it's heavier, out of from here, it will be free from interference. Same thing as HO as well. Okay, this is the list of rare elements, 15 elements plus 2, all 17. However, in fact, actually there are 18. PM, these are promethium rare element isotope, is very rare, extremely rare. Standard is not available. Plus PM is a radioactive. So in fact, PM, no one doing it on PM. Standard you cannot get, and also radiative. So the other thing is just for share with you on the information. For example, this is the rare earth elemental analysis coupling with the ICP-MS with laser ablation. For information, this is complementary from Jabatan Mineral Geoscience in Ipoh, like Pekima with working with Encik Ismail Anwar, Encik Muhammad Zaha to come out this paper, laser ablation ICP-MS. So far Malaysia, there's one unique laser ablation is at JMG Ipoh. So this is the ICP-MS that been used coupling with laser ablation. So in this case, ICP-MS can analyze solid sample, and the laser ablation being used that the fuse bit being analyzed on SRF, same fuse bit can be used, put into the laser to be analyzed. For the same fuse bit. So now we take a look. This is the laser ablation. Okay, like laser ablation, you can see that the energy output is can vary from 1 to 20 Hz. Higher frequency, higher energy. Now look at the spot. Spot size 4 to 200 micron. 200 micron, just a one spot only for the laser. So for these solid sample, in fact, it's very good for geological sample. It can do isotope ratio and so on. And water sample, in fact, laser ablation solid sample, apart from geological sample, you can do like clinical sample hair. Without sample prep, you can shoot the hair to be analyzed. But good on the laser ablation, any form, it can be analyzed. But disadvantage on the laser, we would like to share with you is, you must be matrix matched. Therefore, using fuse bit to prepare the standard, then the sample, fuse bit also for the similar method will be okay. If you are analyzing hair sample or grass sample, the calibration need to be hair standard, need to be grass standard. If you are using fuse bit, mean there is a similar matrix. So laser is good, but it's a matrix matching. Okay. So all kind of sample can be done: plastic, coating, biological sample, bone, everything. No sample prep, just direct shoot. Okay, the sample spot side, we can put like single spot, scanning. It got the CCD camera, which spot we want to shoot on the sample. It got the line scanning, raster, segmented, multiple, mean that line scanning, raster, or depth. It can study the coating or the depth. Different depth, different elemental, different composition. So like those are coating, you can study on it. After the first layer come up, you know the second, what are the, mean that the material is continuous shooting, then it will be a coating. So, and for information, like we have mean that working with JMG, like running on this CRM on this rare element is a REE CRM. So concentration increase mean that the instrument, all the count respond well. So it means that these are different metrics from the rock, different sentiment, this all thing is all different metrics, but good correlation. It means that laser working well with this fuse bit sample. Okay, at the same time, also testing on the different energy, 5, 10, 20 Hertz. Look at the ISD. In fact, its energy increasing, the ISD is getting better. So it means that higher energy, so means that get good precision and stability because it's higher energy to ablate the fuse bit sample for rare earth element. So we also doing like maybe the range or the QC check. You look into it, is within the range across all the rare elements, and also we do the measurement on uncertainty. So this is a measurement on uncertainty. So it's a very good correlation. Laser ablation ICP-MS. But however, for your information, laser ablation system is rather expensive. Just accessory only, the price is even much higher than ICP-OS. So you buy laser alone, it doesn't work. It needs to be coupling to ICP-MS. So overall, it's because not many units, because it's costly on the laser ablation. Second thing is standard metric matching, unless using fuse bit. Fuse bit machine is also not cheap. It's also rather expensive as well. So next is apart from laser, also for information, also rare element using microwave digestion. Microwave digestion for this rare element, and it's ICP-MS with the microwave digestion, set the temperature, and for the rare earth, because it's a sediment that sample like 0.5 gram sample put into this acid for the digestion. And also HCl, hydrogen peroxide, and a little bit on the HF. So for geological sample, need to add in the HF. So we are running on different reaction mode, like run on methane, oxygen, KED mode, collision cell, standard mode. So different element, different reaction gas. So because this rare element is challenging, need to have very good ICP-MS to remove isobaric and polyatomic interferences. So after we run on this method, that you can see like maybe these are the CIM is a very good recovery. Like this is dorite, quartz, very good recovery. It's basically 80 over plus minus within 15% most of the element. Very good. Kaolin, mean that sediment very good recovery. So this is a raw material for this rare earth element. What about the processed rare earth element? The processed rare earth element could be high purity rare earth element, the process. So like the high valuable is finite. Finite, what we mean is 99.999% is finite, high purity. So for this raw material, sample prep is tedious. You need microwave, you need hydrofluoric acid, instrument need to be HF resistant as well. Need to use Teflon, nebulizer, Teflon, spray chamber, platinum cone, and also sapphire injector to run this HF resistant mean that sample. So about for next is high purity sample. High purity sample running will be easy. Basically, it dissolves in nitric acid. Yeah. So it's simple acid dilution only because it's already pure, just dissolve in acid only. So on these high purity chemical will be a little bit different. We call it REE. The ratio of REO versus TREO is rare earth element oxide of interest that we want to purify, mean the customer want to purify, divide by total rare earth element is none of other than the element of interested because we want the purity plus other non-rare earth element. So if we look at the 99% is mean that CO, okay, put it this way, 99% probably ICP-MS also can do it, but we talk about finite ICP-MS will fail to do it, even though 99.999 is 0.001% impurity, is about 10 ppm, but doing many elements, therefore ICP-MS come into the picture for high purity rare earth element. So this rare earth element look into this, it got multi-isotope, a lot of isobaric element interfere one another. So it's very challenging. And coupling with the light rare element, it form oxide, interfere with heavy rare earth element. Like for example, lanthanum oxide interfere with GD and also YB. CE oxide interfere with GD and also GD. So CE oxide interfere with YB. In fact, a lot across all the light earth element interfere on it. So before we analyzing it, let's maybe take a look the interference on the rare earth because you can get easily 4 forces to run rare earth element if not removing valve, or you may think very high or very good sample contain very high rare earth, but in fact it's from interferences. Like for example, this rare element device will interfere by itself on this light rare element oxide. Okay. And then there that probably these are GD also interfere by this PR oxide, and there are some isotope like HR, HO, monoisotope, SMO interfere, TB monoisotope interfere, and the oxide. TM also 100% because you don't have any other isotope, only one. Whether like it or don't like it, that is the only isotope. Therefore, if this present, in fact, just cannot analyzing it. So must do other way, must modify this monoisotope as a precursor to product ion. Mean that we move unlike of interest to other heavier mass free from interference. That is the purpose of good ICP-MS like triple quad ICP-MS using oxygen, capable of doing so. That YB also interfere by GD oxide and so on. Like these are SM interfere by all RU. So many. Yeah. So that is challenging. So now not only challenging, and we have to analyze non-rare element, so many elements, and it has to be very low. Total this all rare element is less than 0.38 ppm. And this is run rare element because we are doing CE. We are not checking on CE. And total rare element present on this sample is CE is 7.5. Total less than 10 ppm is finite. 99.999% purity. So this is a high purity rare earth, is a process rare earth application. So now we look into it. Apart from rare element, now we look into ICP-MS mode. like rare element can be prepared in few speed like lithium borate fusion, and in the ICP-MS mode, like what are the mode that it can be analyzed. For example, look into it, rare earth element itself, almost 80% all are using oxygen mode in the triple quad ICP-MS to modify like dy to dy oxide. It can be mono oxide, dioxide, or trioxide. So depending on the amount of oxygen inject into the ICP-MS. So like E, dy, Er is all oxide. However, apart from this oxide, they also mean that some element, for example, Nd okay, by itself run on standard mode, and like Ce run on ammonia. So they are mixture of ammonia and also oxygen. As you all know, ammonia is hazardous, but ammonia achieve the best performance in ICP-MS because it's hazardous, very good, and remove on polyatomic and isobaric interference in ammonia. So if second best other than ammonia can switch to methane. Methane is not so hazardous, but it's flammable. However, the performance is not that good. If you are going for very high priority, ammonia is a must. If you are going methane, it's challenging. Let's say for raw rare earth element, okay, but for high priority, it's quite tough for methane. So, but anyway, Perkin Elmer ICP-MS is capable to run on ammonia. If customer, let's say, worry on ammonia, you can run on methane. It's able to change to ammonia anytime because the difference on ammonia and methane is a turbomolecular pump being used in the ICP-MS. The thermomolecular pump with using ammonia, it got the argon pulse, mean that to protect the turbomolecular pump. So that is the difference. And apart from rare element, other non-rare element that need to be analyzed because it's an impurity, ammonia is very good. And because other non-rare element, a lot of interference from argon, oxygen, hydrogen, hydroxide, and the matrix or the element. So those elements, ammonia target to remove this argon-related interference very, very efficient. Okay, so this is basically what kind of mode that to be run, and this is checking on the CRM on rare element. You can see that recovery is 100% for all rare element, 10%, and there 80% even below 5%, 20% rare elements 5 to 10%. So mean that in this method you can see that they are laser ablation method, they are fusion method, they are microwave method. However, if some customer, because microwave is not cheap, it's quite expensive, maybe you can try on this hot plate. So need to using HF as well. So you run on rare element, need to be careful because it's exposed to hydrofluoric acid. So no glassware, is all plasticware. Because glassware, you will be kaput if exposed to this hydrofluoric acid. So that is about the rare earth element and geological sample application. So next, I will move to like biological application and also NIOS application. Okay, for biological sample, NIOS application basically is mean that on clinical sample. Clinical sample like those using clinical sample, I would say in Malaysia like UMMC, using Malaysia Medical Center, PPUM or NIOS. Of course, mean that Jabatan Kimia also they are doing it for forensic purposes. So let's say maybe we take some guidelines. Like this is the NIOS guideline from Malaysia. For this Malaysia is listed. What are the elements need to be checked on this mean that occupational safety and health on those workers? Like basically arsenic, beryllium, cadmium, chromium, 6, lead, manganese, mercury. So as you know that this clinical sample is very challenging. Look at the blood itself. Wow, contain of all sorts of forms. It got plasma, it got pellet, it got protein, pellet, leukemia. These all mean that it's a very, very complex sample and high total dissolved solid sample. So like it can be 10 times dilution, but or can put into the microwave sample to be cleaner lah. So that is the urine blood sample composition. So it's complex. Next is urine sample. Urine sample, you can see it's very high total dissolved solid, 2.9%. 2.9%. In fact, normal standard ICP-MS total dissolved solid can stand about 0.4%. But now Perkin Elmer new ICP-MS, we got AMS, all metric system. It can be stand up to total dissolved solid up to 35%, because it's using argon aerosol dilution to dilute the sample from 35% to 0.175% to be able to be run on ICP-MS. So now ICP-MS can run on all matrices, is doing it online. So this is a urine sample, can be 10 times dilution, total dissolved drop down to 2.9%, then you'll be okay. The next sample will be these urine sample, serum sample, and the sample prep, and running on this sample like standard addition method, 10 times dilution. And because using analyzing mercury, we use gold to stabilize mercury. Because gold, if we mercury without adding in the gold, mercury is sticky and you have maybe long carryover. So it forms amalgamation with mercury, so mean that for fast wash out time. This is the urine sample. This is blood sample mixed with 1% TMAH, also added in the mercury gold because to stabilize the mercury. The other sample is serum, is also 1% nitric acid. So this sample like maybe can do direct dilution, or you can use microwave to digest it. So basically the element that analyzing, these are the element. If you refer to the guideline, the method mean that the level is stated, mean that for smoker, non-smoker, lady, mean that adult, those level is stated on this method. You can refer it. Okay, so this is the mean that biological and clinical sample. So next is we are moving into this material sample. Material sample, for example, material is mean that all sort of material. I just quote maybe few, maybe one or application like now currently it will be very high demand on battery. So it's mean that on use of battery. So rechargeable battery, the hybrid car sorting now is high demand of battery global. So now supplier like those Perkin Elmer also look into the battery application. Now we look into it, like for example, this is the battery, is lithium battery, lithium grade. If you look into it, these are the method, these are the grade. It listed lithium must be range of how many percent lithium carbonate. It need to be 99%. It listed all the impurity need to be analyzed, like sodium 0.06%, maximum calcium 0.016, magnesium 0.08. These mean that for magnetic impurity is these 300 ppb. So in fact, for this battery, look into it, the level is all in percentage. For information, this battery application will be on ICP-OES. But because the method or official method is stated on the ICP-MS, even though ICP-MS is very low level, mean that either dilute it down or mean that is to extend the linear category range to do it. So now we look into it, high precision analysis. This is a paper from Perkin Elmer to analyzing battery material using ICP-OES. So apart from lithium, like manganese, nickel, phosphorus, zinc. So it's a mixture of this element. It got the ratio of major component. So this is on the ICP-OES. So now we look into it. In the battery, like major element, calibration concentration up to about 2000 ppm, the calibration. Manganese, phosphorus, lithium about up to about 500. Nickel and zinc, this is the range. Impurity is in ppb level. In ppb level need to be monitored. So this is mean that is to be analyzed on the ICP-OES. So we check on the recovery, major and also minor element, and is achieve good recovery. So I would say that you can look into it. It's very good on the recovery. Plus minus all are within mean that 10% for major and also minor element. But apart from battery, apart from elemental, as you know that battery is not only the elemental, it also involves some other instrument as well. So depending on the cathode, like you may need FDR to check on electrode sheet, the path. You also need probably GCMS, DSC, TGA for different, depending on you are checking on cathode, separator, electrolyte, or mean that what are the components in the battery need to be checked out, because there are many parameters need to be checked on this battery. So in fact, by now I've quickly run through you on atomic spectroscopy to cover many different type of application. In fact, still got a lot more application. Every customer got their own application need different. So depending, but those are common application being used in Malaysia market segment. So next is I would like maybe to quickly also to share with you which atomic spectroscopy will be most suitable for you for your lab. Okay, mean that is we will look into it. How many samples do you have in a day? If you got 1 or 2 elements, okay, AS will be good enough. Either flame or graphite furnace, depending on what level, what element you want to do. If your element, let's say more than 5 elements, maybe good to consider ICP-MS because it's very fast. So one shot you can do more elements. So depending because the price of course ICP is much higher. So next is are you doing the toxicity element? Arsenic, lead, mercury, cadmium. These are the toxicity elements. It can be the traditional herb, pharma, food, clinical, diode, safety. Anything to do with the safety element on these big 4, as long as mercury is there, you need microwave and ICP-MS. Yeah. Okay. So next is what about supplement element? It can be supplement. These are high concentration supplement, nutrition, raw, soil. These elements are very, very high element. So if you are doing on this element, let's say for example, they are in few hundred, few thousand ppm. So if you refer to official method, AOAC method or nutrition method, European method, it will be listed on ICP-MS. Even though those customers having ICP-MS, it can be done, can be optimized. Yeah, to go for this high ppm level by using ICP-MS. But official method is on ICP-MS. Look into here. Well, every instrument got its own niche market lah. Okay. So next is are you doing sulfur, boron, phosphorus? Boron and phosphorus is required on agriculture application. Sulfur, boron, phosphorus is required in oil and gas industry, and palm oil industry also need phosphorus. If you require to do this element, AA just cannot do it. It must be either ICP-MS or ICP-MS to do it. And next is are you going to do isotope ratio, isotope dilution? If mentioned on that isotope, it must be the mass spec. Yeah, isotope ratio, like maybe you want to do the aging of the rock, that will be maybe on the isotope ratio. If you are preparing maybe on these CRM, like Malaysia, like you all plan to come up maybe CRM to produce CRM, you may need to use isotope dilution to analyze, because very, very good precision. You can achieve 0.08% RSD if you are using isotope dilution, because it's if you are using isotope, although that you achieve very good precision, isotope itself is so expensive because it purifies isotope. So next is are you going to do species determination? Methyl mercury, mercury 2, ethyl mercury, arsenic 3, arsenic 5, organo, arsenic, chromium 3, chromium 6, and selenium, and so on. Species, there are many species as well. So if you are doing so, it will be HPLC, ICP-MS, HPLC hyphenated with ICP-MS. So next is based on element in periodic table. Are you going enough? Oh, food safety, 4 element, 5 element, good enough? Or I want to know all elements present in my sample. I want to do screening. Oh, even though I do not analyze it now, but future I may need to know what is the content. Like archive, digitize your analyze into the archive the file. Future you can recall and analyze. If for research, I want to do whole element in periodic table, 73 elements, 75 elements. If you want to do so, it will have the ICP-OS or ICP-MS. Because AS, or if you buy all holocautlane price, it will be more expensive than ICP. So what are the range you want to do, like PPM, PPB? This thing will link to what application. If the moment you mention what application, we will roughly know what element you want to do, what instrument is suitable for you. So it's you refer to official method or are clearly stated what instrument you need to be used. It's clearly stated lah. But some method, official method, is just weird. It does not include this element, that element. So you need additional hard work to do, maybe validate another method or a combination of the different method to get a full list of validated, accredited lab. So Mercury, if you look into Mercury, is very weird. This method cannot, that method cannot, certain method include, certain method exclude. So Mercury in terms of sample prep is also very interesting. So quite tedious, not easy. And in terms of analysis, also very interesting. It tends to exclude a lot of things. If you want to fully follow this all thing, it costs you a lot of money. Yeah, so that is maybe for information. Finally, is what is your cost of consideration? Of course, ICP-MS is the most expensive, followed by ICP-OS, and also AS, got frame, got graphite, got hydride. These are the things. So now we look into it. This is the principle of atomic spectroscopy. In the AS, we are using flame, air acetylene, or nitro oxide. Okay, temperature about 2000 for 2008 degree. So in this case, 2004 degree, just enough to form ground state atom. Lead become lead atom. Cadmium become cadmium atom. So in this case, it forms the ground state atom, not excited. Therefore, this sample pass through the frame, use a holocautlane lead, pass through the frame. The amount of unlight present in the frame will absorb the light emitted. Let's say lead unlight in the sample will absorb the light from holocautlane lead. So loss of the light for the holocautlane will be measured. And then it converts to the concentration. So you plot the absorption versus the concentration. That is AAS. So in the ICP, we are using plasma. Plasma temperature is much higher. We are talking about 8 to 10,000 Kelvin, about 4 times higher than AS. So electron will be able to promote to higher orbital level, become excitation state. It's not stable. The K emit excess energy as a photon. So ICP-OS, no holocautlane is required. It's an emission technique. It can emit 73 elements. So yours mean that up to user which element you want to analyze. So all wavelengths are available. That is ICP-OS. For the ICP-MS, is the electron dissociated from atom become ion. ICP-MS we measure ion here. So this is AS technique, ICP-OS technique, ICP-MS technique. So these are the instruments. So this is a mercury analyzer. So and now we look into it, the range. AS frame or graphite 2004 need to have holocautlane, mono, chromato, optical, one by one. Mono, it means that one by one detector. So ICP frame go into optic, the detector, solid state detector is light emission technique. ICP-MS we measure ion. It go into the mass spec, then go into the detector. So this AS, ICP-OS, and ICP-MS technique in a very quick review. From Perkin Elmer, we got the full range of the instrument like mercury analyzer, frame AS. Frame also got many model, frame and graphite or integrated got hydride. ICP also got different model. ICP-MS also got different model. So in a very quick, let's say the comparison on this different technique, like ICP-MS can do about 75 elements and with rare element, ICP about 73 element, frame and graphite about 50 over 68 element. ICP-MS we measure on the AMU, atomic mass. ICP-MS on the wavelength. These are graphite furnace, you look into it. AS is until 190, therefore sulfur element is missing out. So in the AS sulfur, it cannot be done. Like other than sulfur, boron also can be done. Phosphorus also can be done in AS. So typical detection rate ICP-MS is 1 ppt or below for most elements. It now come to the PPT or PPQ level. So ICP-MS typical about PPB level. This is ideal instrument detection limit. The lowest it can go down. So you have to look into like method detection limit for your actual sample running, and also you have to take into account of your sample prep dilution factor. So this graphite funnel about 0.0, you can look into graphite funnel is better than ICP, but very slow. One run take you 3 minutes. If one sample 3 replicate or it's nearly 10 minutes just for one element, you imagine how slow graphite is, but it's cheaper. So this is frame PPB level. So this is the instrument calibration. Linear dynamic range, you can go from low to very high. Like ICP-MS, it 12 order of magnitude. It can be PPT level until high PPM level. Yeah, it can go up to it. ICP about 6 to 7 order, PPB to high PPM level. Yeah, range. Then graphite furnace about 2 order of magnitude, very short. Chance